A-roll. Have you ever wondered how we can predict the future even in small ways? Imagine you're growing a plant. It seems logical that the more sunlight it gets, the taller it will grow. But how much taller? What if we could turn this simple observation into a powerful predictive tool? Today, we're going to explore a fundamental concept in data science that does exactly that. We're talking about linear regression. At its core, it's a way to find a simple, straight-line relationship between two things. B-roll. As we talk, imagine a blank canvas. Now picture tiny dots of light starting to appear scattered across the space. Each dot represents a piece of information, a single observation. These points might look random at first, but hidden within them is a pattern, a story waiting to be told. Linear regression is the key to uncovering that story, drawing a line that makes sense of the chaos. A-roll. To understand how this works, we first need to get familiar with two key players, the independent variable and the dependent variable. Think of the independent variable as the cause, the thing we can control or measure. In our plant example, that's the amount of sunlight. The dependent variable is the effect, the outcome we're interested in predicting, the plant's height. We believe the plant's height depends on the sunlight it receives. B-roll. Let's switch to a more classic example, house prices. On a graph, we'll place the size of a house, say in square feet, along the horizontal x-axis. This is our independent variable. On the vertical y-axis, we'll put the price of the house. This is our dependent variable. Now, let's plot the data for dozens of houses that have already been sold. Each house becomes a single point on our graph, defined by its size and its final selling price. You'll notice the points aren't random. They tend to trend upwards and to the right, a roll, so we have our scattered data points. Now what? The main goal of linear regression is to find the single straight line that best represents the relationship in our data. We call this the line of best fit. It's like drawing the most accurate summary of the trend. This line won't pass through every single point perfectly. That's almost impossible in the real world. Instead, it aims to get as close as possible to all the points collectively. B-roll. Imagine a straight line appearing on our house price graph. At first, it's at the wrong angle. The animation shows the line tilting and shifting, trying to find its perfect position. As it moves, we can visualize the distance from each data point to the line itself. These distances are called residuals, or errors. The algorithm's job is to adjust the linear slope until the sum of all these errors is as small as possible. The final position is our line of best fit, A-roll. This is where the magic of prediction comes in. Once we have our line of best fit, we can use it to make educated guesses. Let's say a new house comes on the market, and we know its size, but not its value. We can use our model to estimate a fair price. We simply find the house's size on the x-axis, move up to our line, and then look across to the y-axis to see the predicted price. B-roll. The animation on our graph demonstrates this. A new value for house size appears on the x-axis. A vertical line extends up to the best fit line, and a horizontal line shoots out to the y-axis, landing on a specific predicted price. This isn't just a guess. It's a data-driven estimate based on the trend learned from all the previous sales data. It's a powerful way to turn historical data into future insights. A-roll. So, let's recap. Linear regression helps us model the straight-line relationship between an independent variable, like house size, and a dependent variable, like its price. By finding the line of best fit that minimizes errors, we can build a simple yet powerful model for prediction. It's a foundational technique, but its importance can't be overstated. From finance and economics to biology and engineering, linear regression helps us understand the world and make smarter decisions. B-roll. The screen fills with a fast-moving montage of different applications, stock market charts with trend lines, medical data being analyzed, and futuristic dashboards displaying predictive analytics. All of these advanced systems often rely on simple principles like the one we've discussed today. It's a reminder that sometimes the most powerful insights come from drawing the simplest of lines.